If you looked at the classwork today that I posted, it's numbers 1 to 6, 15 to 17, and 19. So 1 to 6, I'm going to kind of jump around a little bit. Just kind of a heads up if you are following along in the book, which I recommend that you do. But problem number 1 basically says, you've learned 3 important things about logs so far. So let me share my screen. Okay, so for problem number 1, it says, what is a logarithm and how can equations be converted into another form? Mommy! Hey, Mommy. What, baby? Oh, I see it. Drove by. Okay, so what is a log? This says log with a base of b of x. Let me see if I can get it to focus a little bit better. Means to determine the exponent needed for b to get. Garbage has to do with the garbage. What? They dump them, they back them, put them in the dump. Mm-hmm. So again, log base v of x means to determine the exponent needed for b to get the value of x. I probably should have put like bullet points here. A log function is the inverse of an exponential. So kind of underneath that, the inverse of y equals b to the x is y equals log base b of x. Those are inverses. Not to be confused with how we're going to rewrite them. A log function can be rewritten as an exponential too. So not only are they inverses, but they can also be rewritten as an exponential. This is a little bit confusing, but we should know that y equals log base b of x is equivalent to b to the y equals x. Those mean the exact same thing, just rewriting it differently. And this last bullet point, that's kind of what we've done the most of, is practice rewriting in the other form, because that helps us determine the exponent and see it the other way. We did the inverse by graphing them mostly. What else we should know is the log button or the log key on your calculator uses base 10. And then it says kind of what does a log graph look like? So we know it goes to that point 1, 0, unless it's shifted. And then we have our asymptote here. I'll draw that in just to remind you. And then the parent function, or the graphing form, I'm sorry. The same thing as we've always done. Y equals A, then the function. It can have a base, or the base could just be 10 of the log x minus h plus k. Those are what you should already know about log coming into this chapter, and that you'll want to know for your test tomorrow. So 7-2 wants us to compare the graphs y equals log base 2 of x. And I'm going to do a different color. And y equals log of 2 to the power of x. So what's happening on this problem, it says Marta wants to graph this, but accidentally types in this. So what we're going to do, we're going to sketch both of them. I'm going to pull them up on Desmos. We should know what this first one looks like, though. Give you a minute to set up your axes. Again, I'm going to do a different one in the other color. Okay, so I typed these in already. We know log base 2 of x, or we should know, I just reviewed it, looks like that. That it goes through the point 0, 1, because it's not shifted at all. There's no h or k. Sorry, 1, 0. Has this asymptote. And kind of goes like that. Just a little quick sketch. But then if we graph this other one, y equals log of 2 to the power of x, I'm going to click this circle to turn it on. We can see we have a linear equation there, or a linear graph, I'm sorry, that goes through 0, 0. So it goes through 0, 0, and then it shows the point of intersection there. You don't need to write those coordinates down. They are not significant. So sketch both of those. So from just the graph, we can tell that they're different. But then the book says for part B, show that they're different by converting into exponential form. So y equals log base 2 of x. Looking back up here, converting this to exponential form, the base becomes the base of the exponent. The y that was alone becomes the exponent. And then what we took the log of is alone. So y equals log base 2 of x is 2 to the power of y equals x. baby.
Are you done?
No, I'm not done.
Then
Then the second one, because there's no base given to us, again, we should know that the base is 10. It's just implied and we don't write it. That's really hard to tell. Almost looks like a B. That's a 10. So if I rewrite this in exponential form, this is the base of 10 to the power of y equals 2 to the x. Upstairs. And so we can see right here that these are not equivalent. So we could check it by graphing calculator or Desmos, or we could change them into their exponential form and see that they're not the same. All right. So on this problem, this is called a counterexample. So we showed that these are not the same. So in general, we would know that these y equals log base b of x is not equivalent to y equals log of b to the x. They just chose the 2 for the b, but since we showed that it wasn't true for 2, that means that this isn't always true. So that's what we call a counterexample. So on 7-3, we want to decide if these are true or false. And I'm going to write them all out. So A is log base 5 of 25. Is that equal to log base 25 of 5? B is log of x squared. Is that equal to log of x, all in parentheses, and the whole thing squared? C is log of 7 to the power of x. Is that equal to x times log of 7? And finally, D is log of 2x. Is that equal to log base 2 of x? Sorry, move this up so you can see all of those. But again, they're in your book. So we're just determining if these are true or false. You have 2 different options to try to do these. You can pull them up on Desmos and graph the left side as y equals and the right side as y equals and see if they're the same. You could type these into your calculator and see if you get the same thing, right? You can type this left side in, hit enter, right side in, and you could do the same thing here by picking a number for x on the ones that have x. So we'll just kind of split these up. Let's say, I don't know, if your birthday is like the 1st through the 8th of the month, whatever month it is. No, let's just do this. If your birthday is January through March, you're going to do A. If your birthday is April through June, you're going to do B. If you were born in July through September, you're doing C. If you were born October through December, you're going to do D. So just take a minute or two, decide what way you want to do it. Do you want to try to do y equals this and y equals this and type them into Desmos and graph them? Or do you want to try to just use the log button on your calculator and see if they are true or false? So like I said, I'll give you about a minute or so. And if you don't know what one I gave you, just pick one. But we need to make sure everyone's getting them done. So hopefully there's at least like 5 of you so we can check. And so once you figured it out, private chat me. That way, if other people are still working, what one you're doing and then true or false. Don't just say false. I have no clue what one you're doing. On A, log base 5 of 25, we should know what that is. Remember, you're asking yourself, what power do I take 5 to get 25? So we should know that we're going to get 2 on this side. So we're saying, does 2 equal, oops, log base 25 of 5, which is 1/2. So these are not equal. That's false. B, it looks like, so if you were trying to type B in again, you could just do log of 10 squared. I just chose 10. Is that equal to log of 10 and squaring the whole thing? Notice this squared is outside there, so these are not the same. 2 doesn't equal 1 is false. And finally, the book tells you one of these is true, which means C is true. And I'll just confirm that on my calculator. Again, if it's true, it should work with every single number, and we would want to prove that. But if I do log of, gosh, I'm having a hard time here, 7 to the power, let's just choose 3. Is that equal to 3 times log of 7? And we see that it worked. And so if you picked another number, you would see that it works again. I know I'm almost out of space down here, but basically this is what we call the power property of logs, which I think we'll end up getting more official notes in a minute. But the power property says that log base m, nope, that's not base m, sorry, log of m to the n. So log of m to the power of n is equal to n times log of m. Basically, you can either have it as an exponent or you can bring it out in front to multiply it. So that's what we're going to call the power property. And that's what part C showed was true here. All right, questions, anything before I flip the page? Okay. So for 7-5, the equation is 1.04 to the power of x is equal to 2. So before right now, to solve this, we can guess and check or graph it. That's pretty much if something like this came up, because we can't write this in the same base. We can't rewrite 2 as a power of 1.04. So the only way we would know how to do this, and we're not going to do this, is we would just guess and check. Again, this is because the bases aren't the same. So basically it says, well, then there has to be an easier way. So to solve this, we're going to kind of do something a little bit new. we're going to take log on both sides. So what I mean by that is I'm going to just kind of, you know how we use sine and cosine and like we do inverse of the trig and put that on each side. We're just going to take log and put it in front of both sides. So log of 1.04 to the power of x is equal to log of 2. So I'm just putting a log in front. I'm doing the same function on both sides. So now I'm going to use that power property that we just went over. And the power property says, well, if I'm taking log of something that has an exponent, I can bring that exponent out in front. So that's equivalent to x times log of 1.04 equals log of 2. If I'm trying to solve for x, and this is x times something, we would just divide both sides then by log of 1.04. So now I'll just use that color. X is equal to log of 2 divided by log of 1.04. So log of 2 divided by log of 1.04. So approximately 17.673. So to check our answer, we could just go back and plug it in, 1.04 to the power of 17.673. And we see that that's pretty much 2. So yes, we could rewrite this in log form. The reason that this is an option is because not every calculator, nowadays they pretty much do, but not every calculator had the base button on it. And especially if you're using your phone as your calculator, which I don't recommend, but you can. It's harder to do the base on some of those. And so this might be easier to type in than it would be to type it in with the base of something. So remember, we could change this into our other option is change to exponential, or sorry, to log form. This is exponential. So if I change this to log form, it's log base 1.04 of 2 is equal to x. But if you're having a hard time typing this into Desmos or your calculator, this is much easier to type in because you don't need the different bases. But these will get you the same thing. So I will confirm that on my calculator to show you. Log base 1.04 of 2 gives me 17.673 rounded. Any other questions before we move on? Okay, so for 7-15 then, I want you to try this method. Even if you know how to do this way, just try it. we want to, what are we trying to solve? So I want you to solve 2 to the x equals 30. See if you can solve that using this method. When you're done or reached kind of where you think you can and maybe get stuck, just type it in the chat. Again, it can be to me privately. You can tell me you're done. You can tell me the answer. You can tell me I got to here and I got stuck. You can tell me you don't know where to start, but I can't see what you guys are doing, obviously. So let me know because I'm not sure how long we'll need for this one. Yeah, and it looks like everyone that's given me an answer so far has gotten it correct. And again, if you're stuck, that's okay. It's the first time we did this. But that's why I kind of tried to write the directions. Take log on both sides. Then you use the power property. Remember, the power property says if you have log of something to some power, you can bring that and make it just the coefficient. And then to solve for x, you divide by the log on both sides. So you should end up with y or x equals log of 30 divided by log of 2, which is approximately 4.907. So for 16, we want to kind of try to generalize this. So if I have log base b of y equals x. And again, pretend I don't have the base button on my calculator. The older calculators didn't have it, and sometimes it's just hard to type in, especially extra buttons, or on Desmos, it can be hard to get it. So if I rewrite this in exponential form, it's b to the x equals y. Well then, if I take log on both sides, log of b to the x equals log of y, then that power property says x times log of b equals log of y. And I can divide by log of b. And that would tell me x equals log of y divided by log of b. So right here, notice that this is x equals and this is x equals. Together, these two things tell us that log base b of y is equivalent to log of y divided by log of b. Sorry, this kind of overlap each other a little bit there. But since this was x equals and this was x equals, that means they're equal to each other. So if you don't have the base button on your calculator, or if it's hard to find, you can always just type this in. All right. So kind of moving on to try to find more log properties or rules, and we'll summarize them all in a minute. Think back to our exponents, back to Math 1, Chapter 1, x to the m times x to the n is equivalent to what? And x to the m divided by x to the n is equivalent to what? So when we multiply, and they have the same base here, x to some power and x to some power, what do you do to the exponents? So if this said x squared times x to the 7th, what would that be? What do we do to exponents on a multiplication problem? Yes, a few people are chiming in. Thank you. And yes, you need to know this. This is on your test tomorrow. You add them. That just becomes x to the m plus n. What do you do on a division problem? What do you do to your exponents? So again, example here, I should have x squared times x to the 7th, we know is x to the 9th. We just added them. Yeah, and then this is x to the m minus n. So x to the 7th over x squared, we should know is x to the 5th. Those are just an example to show you. So we want to try to find equivalent properties for logs. So if you look at B in your book, there's a lot to it. So part I says log of 5, number 1, I should say, plus log of 6. That's equal to log of what number? That's what we're trying to figure out right here. Number 2 is log of 5 plus log of 2 is equal to log of what single number? Just like up here, we wanted to rewrite it with one single base. We want to rewrite this as one single log. How you're going to do this? You need your calculators. I'm not going to do all these. I want you guys to try them. You're going to hit log of 5 plus log of 6. So this side you get 1.477 approximately. You want to know what single number, and you're just going to be guessing and checking until you get the right answer. Does anyone have a first guess they want to give us? What log of what single number can I take here to get 1.477? So again, I'm trying to find 1.477. What single number do you think I can take the log of? Anyone want to give me a guess or something to try first? So if I try 11, I don't get 1.477. So you need to try another number. And yes, some of you are giving me the correct answer. Thank you. But now I want people to try to figure it out. So now I could try log of 15. Still not 1.477. So we can see I need to go up. Log of 20 doesn't work. Log of 25 doesn't work. Again, I'm just guessing and checking. Log of 30, and I got the right answer, log of 30. So log of 5 plus log of 6 is equal to log of 30. Try this second one. log of 5 plus log of 2 is equal to log of what single number? So again, on your calculator, you're going to type in log of 5 plus log of 2, hit enter. Then you're going to guess and check this other one. Then we'll generalize it for number 6. We're going to skip some of the other ones. All right, so a handful of you have already given me the answer. So again, what you're going to do here, I said log of 5 plus log of 2, and we get 1. What single number can you take the log of and get 1? Which would be 10. Log of 10 equals 1. So look at our numbers here. Log of 5 plus log of 6 was equal to log of 30. Log of 5 plus log of 2 is equal to log of 10. What do you do to the two numbers that you're taking the log of to get this single log? So log of m plus log of n would be equal to log of what? What would I have to fill in right here? What do I do to the m and the n to take one single log? Yeah, we're just going to multiply them. That would just be mn.
Mommy,
What, baby? Go get some clothes on.
but they're not putting them on.
Okay, I will help you in a minute. All right, and then try these on part C. There's 2 of them, log of 20 minus log of 5 and log of 30 minus log of 3. Bring me your clothes that you had on and I'll put them on you, okay? Can you do that, please?
No.
So log of 20 minus log of 5 is that number. And so a few of you are saying, well, that's equal to log of 4, which is correct.
I don't want to be on your
And then same thing here,
knee.
log of 30 minus log of 3. We get 1, which we know log of 10 is equal to 1. Yeah, so perfect. A few of you already said it. So when you're subtracting, this becomes division, m divided by n. Sorry, you can't really see that down there.
Nine, 8, 7, 1, 2, 1.
So I'm gonna kind of just put all of these together. So you have them all in one spot. And if you just want to highlight them from today,
1, 2,
what we just did, we have 4 different properties. We have the product property. Sit here. The product property is the one, so log of m plus log of n equals log of m times n. The quotient property, so product we know is multiplication, quotient we should know is division. We do division when we're subtracting 2 logs, and they have to have the same base for these to work. But it works for any base, not just base 10. Log of m divided by n. We did the power property earlier, which the power property is log of m to the power of n is equivalent or equal to n times log of n. I'm sorry. Whatever the exponent was, we can just bring that in front and multiply by it. And then the change of base, again, this one is not used nearly as often. This is only if, what's it called? You don't have like the base button easily accessible on your calculator. This says log base b of y is equal to log of y divided by log of b. So those are the 4 properties that we kind of came up with today. Like I said, this bottom one, it's not nearly as important unless sometimes it comes up though. So, but you should be able to get to it by just kind of doing what we did, rewriting an exponential and then solving for x. But things like the SATs and different tests where you don't always get a calculator, you have a part that's no calculator, it would be helpful to be able to do this. That's another reason why that's beneficial. But we're going to be using these properties quite a bit throughout this chapter. We're going to focus on the product and quotient property right now on the resource page. This resource page, if you printed it, is problem 19. If you didn't print it, it's not that much to write out. Yes, it takes up a whole page, but it's really just this bottom part. So this resource page, like I said, is problem 19. It's in your book, not written as a table. I think the table helps it. So what we're doing here is we're just kind of filling it in. So this says log base 3 of 60 is equal to log base 3 of 6 plus something. Again, I'm going to tell you all of these have to be log base 3 in order to be equivalent. They all have to be log base 3. So remember, the product property says if we add 2 logs, that's the same as multiplying them. So what do you multiply 6 by to get 60? Yeah, not a trick question. So this would just be log base 3 of 10. Log base 3 of 6 plus log base 3 of 10 is equal to log base 3 of 60, because you just multiply the 6 and the 10. Well, this is saying this whole top row is equal to log base 3 of 60. So again, we're adding again, which means we multiply the 2 numbers. 3 times what number is 60? Yeah, so that's log base 3 of 20 because we're just multiplying. Quotient property. Quotient means division. When you subtract, you're dividing. 120 divided by what number is going to give me 60? Yep, that'll be 2. 120 divided by 2 is 60. And then same thing, 240 divided by some number gives me 60, which is 4. 240 divided by 4 is 60. This next one, they left them all blank. You get to pick. So log base 7 of 36. We want to write that as a product property 2 times. So that's going to be log base 7 of something plus log base 7 of something. So ask yourself, what 2 numbers do I multiply together to give me 36? You could do 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. I'll put 6 and 6 there. Pick a different one here. Log base 7 of something plus log base 7 of something. These 2 numbers have to have a product of 36. For the quotient property, again, it has to be log base 7. And these, whatever numbers you choose in here, when you divide, you have to get 36. So I can do like 108 divided by 3. That's 36. What about this one here? Log base 6 of 9 plus log base 6 of 2. What's that the single log of? Log base 2 of what single number would go right here? Yeah, a few of you, thank you. So this would be 18. Because 9 times 2 is 18. Down here, they only give us one. Log base 25 of 75 minus log base 25 of 1.5. Again, we know it's log base 25. To figure out what it's the single log of, you do 75 divided by 1.5. That's the quotient property. If we subtract 2 logs with the same base, to make it one single log, we divide those numbers. So that would be 50. Is this making sense? Does anyone need me to do 1 or 2 more? Because I'm going to expect you guys to finish this. And again, there's more than one right answer. I could have done 360 divided by 10 here. So here, if I want it, basically these, I'm just looking for 2 numbers that multiply to 50. Well, I could do 10 and 5. I could do 2 and 25. I wanted to divide and equal 50 also. I could do 100 divided by 2. So you're just kind of asking yourself, like, what numbers multiply to give me 50 and what numbers divide to give me 50? So here are the properties again if you need to see those. So before we go, a couple of things to remind you of. Tomorrow is your test. Yes, you need to finish problem 19, that table. And what else was it? There was something else. Well, there was a couple more things, but I don't know if you guys saw the email I sent your parents. This is a couple things. This is going to be my last week with you guys before I go on leave. So Mrs. Morgan is going to be taking over next week. You may or may not have seen. She's been coming into our Zooms, so she's staying caught up on what we've been doing and how I run the class to try to keep everything the same, to be consistent. The quarter ends next week, which is really like the semester. So the grade that you have through next Friday is the grade that's going to stay on your high school transcript. It's the one that colleges will see. So if you're kind of slacking right now, you have some missing work. Missing work from chapter 5 needs to be turned in by tomorrow. If you missed the worksheet from Friday, I did reopen it for you. A couple people asked. So I did that for anyone that missed it in case you want to get that in. But I'm going to plan out, even though I won't be here next week, I'm going to plan out everything for the week and try to make some videos just so everything, at least through the end of the quarter grade, the grading term, will be consistent. So you're going to have a test tomorrow, but then you're also going to have a test on chapter 7 next Thursday, the last day before the grading period. So keep that in mind. I don't know if you have any questions for me, math related, about any of the stuff I went over or anything. I am happy to answer them. Yeah, so someone had a homework question. I will pull that one up in a minute. If you have questions, stick around. If you don't have questions, you are free to go. And I will see you tomorrow, 10 a.m. for your test. With your cameras on. Oh, your test. I think it's 18 questions. All right, so someone had a question on 5-100 part D. Yes, your test is timed. It starts at 10 o'clock and you will be cut off at 11:30. So this is what part D looked like. So pretend this just said 10 to the y equals x. So if that said 10 to the y equals x, we would just rewrite this as log base 10 of x equals y. So this is the same thing. Instead of y, I just have some exponent up there. So this would be rewritten as log base 10 of x is equal to the exponent, whatever that exponent is. Well, that exponent is log base 10 of 4. Well, since these are both log base 10 of something, that tells us that x equals 4. All right. Anyone else have any other questions?
I arrived a bit late. Was I marked absent?
No.
Thanks.
What, baby? In a minute. So Iona, I don't know if you have a minute. If you want, I can walk you through, I can show you how I upload from CudaWorks or to CudaWorks.
That'd be great. Do you want to stop recording or no?
Oh, yeah, thank you.